Hello and welcome to the first science lecture video for 8th grade science class. Here are some hints to help you with completing the assignment correctly. First up, don't write every word down. What I mean by this is don't write the word the or maybe to. Leave out words that are unnecessary. Don't write every word down. If you know something already, maybe just write down the word and not a definition. Next up, pause and rewind, or pause, rewind, however you want to do it. You now have the option to do either one of these things. There are going to be questions that I am going to be asking you. I would like you to answer those questions in your notes. I will be checking those tomorrow in class. I want those answers highlighted. You can highlight using a highlighter or circle it. Just basically make it obvious what those answers are to the questions that I asked during the presentation. And if you have any questions while you're watching this video, please write down any of those questions. My suggestion is to grab a post-it, write the questions down on the post-it, post it in your notes, and then tomorrow in class when I'm coming around, you can ask me those questions. Okay, so let's get started on science processing skills. Science processing skills are skills that people use to experiment or to simply find answers through investigation. And an investigation is a manner in which to find facts. So how do you find answers to a question without the help of the internet, a book, or someone else? Well, you can investigate, but that's not really the answer to the question I have here. What is the manner in which we investigate, or how do we investigate? And we do this by using our senses, or observing. You are going to observe using your 5 senses. And here are a couple pictures just to remind you what the 5 senses are for us humans. When it comes to observations, there are 2 types of observations. You probably know these from last year. I'm just going to go over them again, and those are qualitative observations. They describe a quality of something. It's usually an adjective. Examples of this would be green grass, large book, happy dog. You probably have some other examples that came to mind, especially since you did your science fair projects last year. And the next one, you probably know this one already too, quantitative observations. These are observations that include a number or a quantity. My examples, 6 pencils, 4 centimeters, 200 grams. Now in class, we will be doing a large amount of quantitative observations, and there are some tools we'll be using often. These are the ones we use most often. First up, right here, and that's a ruler. And we use that to measure length, width, and height in centimeters. We are using what you guys refer to the metric system. It's actually known as something else, but that's for another time. Next up, these glass vessels right here, those are graduated cylinders. And they're used to measure the volume of liquids in milliliters. In certain instances, these right here look very similar, and they too are used to measure the volume of liquids in milliliters. These are beakers, and as you can see, they are used in the same manner as a graduated cylinder, but under different circumstances. And last, you probably know what this is. You probably called it a scale before you see what my answer is, and we do not call these scales. You probably remember now that they're called a balance, and these are used to measure the mass, but not the weight, of an object in grams. You'll be learning the difference between mass and weight this year. This is not a very accurate picture of the type of balance we use in class. I will be showing you those shortly. Communication is our next science processing skill. So observing or observations were first. Now it's communication. Communication, that's the sharing of data or observations when we talk about science. Ways we do this most simple way is talking about them. You'll share your information with your lab partners or other people in class. If you were actually pursuing a career in science, you'll probably be publishing books or articles, or holding news conferences like the one that they had recently for the new dinosaur that was discovered, or the new element that was just found. And finally, lab reports. That's how you will be communicating your results to me. All right, next skill. classifying. And that is putting data collected from observations into specific groups based on similarities. So if I had a bunch of pictures, I can put them into two groups, boys and girls. Next up, on the bottom right here, if I had measurements of mass, I have start mass and end mass. These are similar because they were the masses at the beginning, and these are the masses at the end. Inferring, our next processing skill. Okay, when we infer, we draw conclusions based on stuff we know already. Observations and prior knowledge is a more professional way of saying that instead of just stuff. An example of inferring. I can infer from my mother's scowl that she was not happy with my new hair color. So if I was to explain this to you, I observed my mother's face, and I came to the conclusion based on past experiences with the face she made. Next up, making a hypothesis. You guys have had experience with this, and a hypothesis stating the expected outcome. An example of a hypothesis, this is what I have. The greater the amount of organic matter added to the soil, the greater the bean growth because organic matter adds nutrients to the soil. Now this does not look like the type of hypothesis you are used to. You are used to the if, then, because format, and I do use that format in this class too. I like that format, and what I would like you to do right now, this is your first question that you have to answer, I would like you to rewrite this example of a hypothesis using the if, then, because format. I would like you to try. I am not expecting it to be exactly what I plan on it being, because it might not be exactly what I plan on it being, but it still may be a good hypothesis. So please take a second and write down this hypothesis reworded using if, then, because format. And press the pause button, because I'm going to move on. A hypothesis always needs a because. Otherwise, it's just a guess. And I would like you, for your next question to answer, to write a hypothesis for the following question. Does classical music help students concentrate while studying? Okay, so press pause and write your hypothesis for this. You can use the format that I have up here, or you can use the if, then, because format. Both of them are acceptable. Okay, next skill is designing an experiment. When you design an experiment, you're going to have variables or factors that can affect the results of an experiment. The independent or manipulated variable is the variable that you are going to be changing during the investigation of the experiment. In the example or the hypothesis I gave you before about classical music helping with concentration, the independent or manipulated variable is whether or not they are listening to classical music. The next variable in an experiment is the dependent or corresponding variable. This variable is the one that should change after you've changed the independent variable. So if I change the independent variable of whether or not somebody is listening to classical music, then I should be expecting to see a difference in how well they perform on their test. And that's the stuff that I can write down. That's my data. Your dependent or corresponding variable is the thing that you're usually measuring to see if something, if the independent variable worked. Other parts of the experiment are your constants, sometimes called controls. I like to use constants for everything else because controls are used in a different manner. So the constants are the ones that never change. Only the independent variable is the one you change. This one changes because of it, the dependent, everything else is kept constant. And then in an experiment you can have two test groups, control group, where everything stays the same, and you use this as a baseline to see whether or not your other group, experimental group, is doing something. So this is the one where you put in, where you have your independent variable and you're changing it, and if your independent variable is working, your experimental group should be different than your control group. I'm curious now, another question, do you think you can have an investigation or an experiment without a control group? If you do think so, can you give me some examples? Okay, so can you have an experiment without a control group? Okay, so let's move on to the next skill, and that is collecting data. When you collect data, I suggest you do yourself a favor and keep it organized. The best way to do this is to set up a document for collecting before you begin. And in that document, you're going to want to use units. So if you're measuring something with a ruler, You need to have centimeters there. You should keep it organized. The best way to keep it organized is using some sort of table. So this is a great quantitative data table. And this is an example of a qualitative data table. Okay. Now that you've collected your data, your next skill is to analyze the data. So you're going to look at it to see if you see any trends or something happening that keeps happening. Best way to see this is graph it. Line graph, bar graph, pie graph. These can help you visually see if there's any trends. Now in my class, when you come to an analysis or the analyzing data step, not only do you usually put a graph, but you have to explain what that graph is showing. In the lab, the last thing that you usually do when you're doing a lab is draw conclusions. Now for me, in my class, I expect you, when you're drawing a conclusion, to state whether or not your hypothesis was supported. Not correct, not true, supported. I will go over a little bit more on why that is in class. After you've done that, you have to evaluate the procedure that you used during your experiment and account for any flaws, things that probably weren't the best, things that could have been done better. You also have to state any errors that could have affected the experiment, variables you couldn't control, or a mistake that came up. And finally, you're going to develop another investigation based on your findings. I'm not expecting a full procedure, I'm expecting like an objective or a purpose, a new question to answer, or even a new hypothesis. Okay, so you finish your experiment, you share your results, and now you are in this stage, the after the experiment stage, and this is where you can come up with a theory. If you and many other scientists come up with the same results or similar results, then you have a theory, a set of ideas that tie together many observations. They're well tested, and there's many people involved, not just one. So you can never just have your own theory. And a law is something that describes how some part of nature acts under certain conditions. We always see this happening. That's what a law is. Okay, so what to expect tomorrow in class. You're going to share your answers. I'll be putting you in your lab groups and you'll share your answers. If you have any questions, you can ask your lab partners or you can ask me. And we will be doing our pretzel lab. And to get you started for that, this is your last question for this presentation. I would like you to create a hypothesis for this question. What type of package leads to less broken pretzels, a box or a bag? And we are going to be using those small little yellow boxes. It's Bachmann pretzels. They're yellow and they have a plastic covering on top. And we'll also be using little Ziploc bags. Okay? So those are the two you are comparing. Best of luck creating your hypothesis. I don't think you really need any luck, but I'm saying it anyway. I will be seeing you tomorrow, and I look forward to our first lab. Goodbye.